I wanted to do a quick little video on the OSI model review. So the first thing that I think that you should do is know the layers of the OSI model in order. And I think the easiest way to remember it is the top down. So 7 is application, 6 is presentation, 5 is session, 4 transport, 3 is network layer, 2 is data link, and 1 is physical. So just a quick little network diagram just to kind of help you remember what we got going on here. So we got a couple key things that we need to talk about. Over here, I'm going to draw the host. A host is anything that you're trying to connect to at the end of a network. It can be a computer, it can be a cell phone, garage door opener. It's an end device, END, end device that a user would interface with. And just to help keep things clear, I'm going to do data link in green, and I'll do my network in yellow, and I'll stay black for physical. So physical connections, things like Cat5e cables. That's what we have at school. This could also be a radio signal. It could also be light or fiber, as in fiber optics. So when you connect your computer to the next device in a network, you're going to connect it to a layer 2 device, and it's going to be a switch. And you're going to connect your network interface card to your switch. So a layer 2 device is a switch and a network interface card. Now, network interface cards and switches have MAC addresses. And if you want to see what a MAC address looks like, you go to your computer, you type command prompt, and use ipconfig, and it will show you what that looks like. I'll show you some of this stuff probably in my next video. So we're drawing the OSI. We're drawing the OSI model. The OSI model. A couple things you need to know. It's a model for host-to-host communication. That's key. Host-to-host communication is key. And it's over a network. Those are the three kind of things I want you to think about. Host-to-host communication network. So a network is a collection of a lot of devices that operate together. So our switch has to connect to another device. And this device is a router. Now sometimes in home networks, the router and the switch might look like the same device. It'll be integrated, but really it's doing 2 or more different functions. So that's our router. The routers have IP addresses. So inside your network and you're outside your network. So a router connects networks. The router lives on 2 networks. So the purpose for our discussion on this side of the network, sorry about that, and this side over here, for the purpose of our discussion, is the local area network. 2 things that differentiate a local area network is you have layer 2 protocols that work for LANs, like for example 802.3 and 802.11. You've probably heard of those before. That one, 802.3, is Ethernet, and 802.11 is Wi-Fi. And we have so our layer 2 protocols are different. So we talk about speed and we talk about distance. So the LAN, the local area network, the distance is small distances, but the speed is great, extremely fast on the local area network. So addressing at layer 2, MAC addresses. At layer 3, addressing is IP addresses. we have physical connections between our devices. If there's ever a problem at layer 1, our physical problem, if there's ever a problem anywhere, the network will not operate. It will just be dead, and you have to fix it. And so you have to understand the OSI model so that you can troubleshoot your network with a systematic approach. So in this case, our router would connect, at a home network, for example, would connect to a modem. Now, sometimes the router and the modem is an integrated device. It does both. But again, we have a physical connection, and a modem is actually a physical device. And then your modem essentially would connect to your ISP, which that should look more like a cloud, but I didn't draw a very good cloud, so let me try again. I'll just draw a little cloud here. ISP, a lot of people think of this as the internet, which is just really a connection of a bunch of smaller networks out there. Pretty much all networks look like modem, router, switch, host. But our ISP in this case would be connected through the internet and through a bunch of networks to things like Google. Would be connected to things like PowerSchool, like at school. Our PowerSchool server's connected out here to the network. It's addressable. And maybe Comcast, which will come into play later on in my example. And then over on this side, if I'm just going to do a host-host connection, say I'm going to email my brother, I happen to have over on my side, I happen to have an AT&T wide area network. I pay AT&T for my service. My brother has Comcast. And then his cable modem is plugged into his router at home. And then his router is plugged into his switch. This happens to be an integrated device, switch and router in one. And then he's got his PC over here. So let me just color these right. The router is a layer 3 device. Have IP addresses, and they're in charge of routing packets. A switch is a layer 2 device, and its job is to move frames on a network. These are terms that you need to understand. So a switch the data unit it uses is called a frame. This layer 3, we have a packet. We have packet here. We have a frame here. And then we'll talk about how frames and packets kind of work together to work together to deliver information to the right place on the network. So what we've done is we've kind of drawn a little example, a little model, a little network model here, and we're going to use that to explain the OSI model and how it's used to deliver messages on a network. So in my example, I want to talk about an email. I'm going to send an email. So my example, I'm going to email my brother. So I'm going to email Brian Lake at Comcast.net. And I'm coming from Joe Lake at gmail.com. So what we have to do first, when my computer over here on the left, when my computer is getting ready to email Brian Lake, way over here, this is Brian at his computer. So when I'm getting ready to email him, first thing I have to do is figure out what Comcast.net is. Now Comcast.net lives out on the internet. I'm heading to this server right here. I'm not emailing Brian Lake, I'm actually emailing Comcast.net. And then Comcast.net is going to forward that packet to him. But the first thing I have to do is resolve, how do I get to Comcast.net? I need to know Comcast's IP address. So when I want to resolve from a name, Comcast.net, to an IP address, the service that does that is called Domain Name Service. You should know what DNS does. So the first thing it's got to do is, if I type my little message, "Hey Brian, how you doing? Want to come to my house for a Christmas party?" And when I go to hit send at DNS, first thing it needs to do is my computer has to query my DNS server, which is probably out on AT&T's network, which I didn't draw. So it's going to go all the way out here to AT&T. AT&T is going to be my DNS server. and it's gonna keep track. DNS has a record of Comcast's IP address, and the AT&T server is going to send a message back to my computer telling me what Comcast IP address is. When you send an email at the application layer, there's a couple protocols that it will use. SMTP, that's the outgoing email server, and then POP3 or IMAP, that's what downloads to you. So this is outgoing, and it transfers between mail servers, and then that one's for download. You can decide whether you want to use POP3 or IMAP. POP3 doesn't keep track of information on the server, so you have to delete it. If you download it to your computer and your phone, it doesn't know that, so it stays basically alive until you delete it everywhere it downloaded. IMAP, the mail stays on the server, and when you delete it one time, it stays deleted. Different people will use different services depending on what they want, depending on the action that they want, but most people want POP, or most people want IMAP and not POP. So applications, over here, if you want to give me a couple examples of applications, an example of an application would be POP3, IMAP, or SMTP. I also used another example, which was DNS. So DNS is another application protocol, and there's thousands of application protocols. Now, email, you have a choice. You can send it format. There's a .eml format. You can send it HTTP format. So the presentation does file formatting. It also does encryption. If you want to encrypt it, this is where this would happen. File compression happens at the presentation layer. And you can also see it encrypt. Your file formats will happen at your presentation layer. Session, when I go to send an email, I have to have a session. Because I'm actually using Google, so I have to actually log into Google over here. I have to log into Google and establish a session so that when I send my email to Google, and then Google will actually forward my email over to Comcast, who will then deliver the email to my brother. That's the process that happens. So it's kind of a roundabout way of getting it delivered. But you actually have to establish a session, which basically is just basically a connection to a server, or actually a connection to an application. So it establishes your connection, so your logon happens, and it does timeouts. If you don't do any activity, you can set your session to timeout like they would on an online bank. So it maintains and ends your session. Now your transport layer, some interesting things happen at transport layer. The address at a transport layer is a port. So a port address happens at the trans layer. So your IMAP and your SMTP and your POP3, those all have port numbers associated with them. So when I go to email my brother, I have to keep track of what port that the application is listening on for either IMAP or POP3 or SMTP, depending on what device I'm using. So your port happens here. We also have some protocols called TCP, as in TCP/IP, and you have a application transport layer application called UDP. UDP does not error check. TCP does error check. So there's less overhead with UDP. There's less put in a transport layer. When you use UDP at your transport layer, there's less information that gets communicated, but it will not error check. So you need to have a very stable, reliable network if you're going to use UDP. Things that use UDP are things like IP telephones and TCP email and video, where you don't really want big gaps of information missing. Then you'd use TCP. TCP is the most widely used transport layer protocol, by the way. Now your network, this is where routing happens, and IP addressing happens here. Your data link, that is where switches happen. Network interface cards happen there. MAC addresses happen there. Ethernet is a layer 2 protocol. And then physical, we already discussed that. That's Cat5e, fiber optics. Can be a radio signal, can be a laser to transport network, and can be infrared. So there's different types of physical signals you can use as well. Different types of physical cables have different properties that you're looking for. So that right there is a quick little summary of the OSI model, how it's used to transport information over the network. I just want to show you real quick, when you go to email somebody, what exactly happens. And I'm going to use this blue pen. So the first thing happens is at the application layer, a technician has to configure the application and how they want to set those, what they want to use at the application layer. For example, do you want to use IMAP and SMTP for email? You're going to have to use SMTP, but you have a choice between POP3 and IMAP. So first thing happens when I type my email and hit send, the first thing my computer has to do is has to go over the network over here to AT&T's DNS server and find out the domain name that I'm sending my email to. So if you're doing joelake@kentisd.org, you've got to resolve kentisd.org so the email can get delivered to my email server. Once it knows the domain name, what my computer is going to do is it's going to go down the OSI model and it's going to decide, okay, this application, I'm writing, hello, Brian, how you doing? How do I want to format that? Now, I'm most likely going to format it as an email, but I can do a web HTML. I wrote that wrong. It's not HTTP. This should say HTML right here. I can send an HTML email. HTTP is actually a application protocol. HTML is the format for HTTP. Some of you probably knew that. So, and then I have to set up a session with my server. So I'm using Google, so I have to log on to my Google email server, establish a session, and then pick a transport protocol. This all happens at the programming level. So emails are sent using TCP. Interestingly enough, at this layer of the OSI model, a boundary happens right here between layer 3. There's the upper boundary. It's more like programming. Layer is more network and network infrastructure. So the layers 7, 6, 5, and 4 are your upper layers. Layers 3, 2, and 1 are your lower layers. So now I've put my message into a TCP segment, and that's the first time that your message gets broken up into little chunks into little chunks, so that it can send the message over the network. You don't send humongous 100 megabyte files. You send a bunch of little packets over the network. And the first time the message gets segmented is at a transport layer. Then the message, which is segmented by TCP, is going to get handed off to the network layer. So all these little segments got to get handed off down, down, down as it goes down the protocol stack into the network layer. Network layer, we're going to use yellow. So what we do is we take this one little TCP segment and we wrap it basically in an IP packet. So packets are at layer 2. And then that packet, and it's got to be addressed. I need the IP address of the Comcast server because it's going to my brother. That's the first place that message is going to be delivered. And then that packet has to get put into a frame because it's got to get put onto the wide area net or the local area network. Now that frame is going to have a header and a footer, just like the packet had a header and a footer. In this particular case, I need to know the MAC address. So there's different addressing that's happening. I have a port address at layer 4. I have an IP address at layer 3. I have a data link. I have a MAC address. So that's what when you send something out over your network, the smallest thing that it can send, or the data actually gets sent in a frame. And then the frame, inside the frame, like an envelope has a letter inside it, the frame has a packet inside it. And then your network card gets a hold of the frame and it gets ready to deliver it over the network. It needs to know what protocol you're going to use. So my frame, in this particular case, my whole frame is going to get sent using Ethernet on my local area network. Now, it's important to understand that the layer 2 frame is going to change when it hits the modem and goes out over the ISP. So a layer 2, an example of a layer 2 data link protocol would be a point-to-point protocol. More than likely, it's using a point-to-point protocol out on the wide area network. So now I'm down. I've gone through this. I've gone through this whole process, and I'm at the physical layer, and I'm going to actually send bits at the physical layer. I'm actually going to send bits over the network. So one at a time over to my switch. And my switch is to look at the MAC address to figure out what the destination of the frame is. Now, the switch, if it belongs on a local area network, it will just deliver it to another computer. So if it's something that's kind of some kind of protocol that's just going inside the local area network, I'm copying a file, something like that, from one computer to another, it's just going to stay local on my network. If it belongs outside, like Comcast.net, it's going to need to know the IP address and the MAC address of my router. So it's going to deliver that frame to the MAC address of my router. My router is then going to open up the layer 2 frame and read the packet, and then deliver the packet. In this particular case, is going to have to deliver the packet out to, it's going to deliver the packet over to Comcast. Exact same process happens. The packet shows up into the network. The network card has to look at the frame. The higher up that goes on the data goes on the inside the server. The server is going to have to get rid of the frame and look in the packet to find out who this message is getting delivered to. Comcast web server will look at that and say, well, hey, this got to go to Google. So Google, the Comcast web server, using SMTP, will send my message over to Google to get delivered. So SMTP is the protocol that happens between Comcast and Google. Oh, I said that wrong. The mine is going to, it'll deliver it to Comcast. Since it's going to Comcast at this point, it'll just go straight to my brother. If my brother was on Google, said that backwards. Let me start over. My computer is using Google. My email address is Google, so it's actually going to go to Google first, not Comcast, because it's going to go to my email server, not directly to his. So the packet will get delivered to Google. Google will then forward it over to Comcast, and then Comcast will deliver it to my brother. That's how that process works. It's kind of a lot going on there. For the purpose of the test, I need you to understand the OSI model. I need you to define the OSI model, which is host-to-host communication over a network. I need you to understand the layers of the model in order. And there's a little mnemonic that says, all people seem to need data processing. So A is application, P is presentation, S is session, transport, network, data link, physical. I need you to give me 2 examples of things at each layer. And there's examples up there for you to take a look at. I need you to know that switches and network cards are green ones here. Switches and network cards use MAC addresses. So at layer 2, switches, network cards use MAC addresses. At layer 3, network cards use IP addresses. So network layer uses IP address, and that's where it routes. That's where it routes our packets. I need you to be able to go to your computer and do ipconfig and tell me your MAC address, which will be labeled as your physical address, and I need to know your IP address. So hopefully this little video helped you out when you're studying and preparing for your OSI model test. Give me some feedback. Let me know how it worked out for you.